Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Coordinate Arrows by Richard, and it's SVS number 448, which is the Sudoku variant series, which Richard basically does for every different type of variant he likes focusing on. And here are the rules. We need to apply classic Sudoku rules, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We have digits on an arrow, spell out the coordinates for that digit. That is the sum of both digits on that arrow. The row number is written on the tail of the arrow, and the column number is on the sharp tip. For example, 1 and 4 gives a 5 in row 1, column 4. So that would be 5, right? Because this is the row. So in row 1, this is the column. In column 4, we have to have something that sums up to what the sum, that must be the sum of these two digits along the arrow, which is 5. 1 plus 4 is 5. Every arrow contains different coordinates. Okay, so that means you cannot put pointing to the same coordinate or the same digit in the coordinates. And digits may be repeated on arrows. So you could have something like, say, 2 and 2, which saying row 2, column 2 has to have a 4, which actually is satisfied by that. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So on coordinated arrows, you can never have a 9, right? Because 9 plus another digit in normal Sudoku is at least 10, which is not going to be a digit. So in box 9, we have 4 arrows all being in the same box. So therefore, where's the 9? It must be here. That means we are guaranteed a 1 and an 8 in this set. So it's either going to be 1, 8 is a 9 or 8, 1 is a 9. But 8, 1 can't be 9 because we already have a 9 in that row. So it must be 1 and 8 is a 9. So this is a 9. And we are pointing to it already. So that's and all the rest of these must be some combination of 2, 7 adding up to 9, 3, 6 adding up to 9, and 4, 5 adding up to 9. Because if we don't have one of those, say we have like 3 and 5 adding up to 8, the problem is the remaining set would have to be like 4 and 6 adding up to 10, which is not allowed, right? Because that's not a normal Sudoku digit. So we either have 2 and 7 or 7 and 2. We have 3 and 6 or 3 and 6, and 4 and 5 has to have a 9. It cannot be 7, 2, and 7 to add up to 9 because we have a 9 already in that box and in that column. So that means 9 has to be here, and it must be row 7 and column 2. So this is pointed to here. We could have a 6, 3 and a 6 and a 3, 6. That is possible. What we know now is this has to be 1 and 8, and it cannot contain, you cannot have another arrow which has an 8 and a 1. Because then it doesn't add up correctly. I mean, it can't be 9 here, essentially. So 8 cannot be in box 6 along an arrow, And we have to have 9 not be on an arrow. 9 obviously can't be that cell, so this must be 9 here, which forces this to be an 8 here. Okay. So again, we have 1 and 8 adding up to 9, 7 and 2 adding up to 9. It cannot be 2 and 7, so the 1 has to be... So the 7 has to be with 1 here. Okay, so then, again, 1 and 8 is the coordinates. This can't be 1, 8, this can't be 1, 8, this can't be 1, 8, so this is 1, 8 here. So this is 1 and 8 here, because of this having to be 8. We have 7, 2. So we could have 7 here and 2 here. 7 here, 2 here, or 7 here, 2 here. So 2 has to be one of these 3. We have 3, 4, and 6. So this can't be a 3, 6 pair because of 3 in the row. This can't be a 3. This could be 3 going this way, and this being 6. And this could be 3, 6 in any way. Then we have 4 and 5. So 5 can be any of these. And 4 would have to be one of these 4. Because it can't be one of these 2. Okay. Remaining digits in box 6. Let's do remaining digits in column 9. We have 2 through 7, obviously. This cannot be 7 here, because if this was 7 here, it would have to be with 2. But we already have 7, 2 set, and 2, 7 can never be a 9. So therefore, this can't be 7 here. So in box 6, we have 7 and 1. The remaining digits are 2, 6, and 3, 5. 2, 3, 5, 6. You could have 8 and 8. But you can't have 5 and 3 specifically. Huh. That is interesting. Only 1 out of 4 and 5 can be set. And it's already set here. We could have 3 and 6. Or 6 and 3. And we could have both of them. Rest of box 6 cannot be 4, 8, and 9. So we have 1, 3, 5, 6, 7. And 2 could be here. These can't be 7, because if they were 7, that's interesting. They would have to have 2 be here to add up to 9, but we had 2 and 7 pointing to 9, and then we have a 9 in the column, which is not allowed. So these cannot be 7. Where is the 7 possible in column 8? It has to be one of these 2. Because 7 can't be here, 7 can't be here, because this is 7, 2, adding up to 9. Row 7, column 2. That means this can't be 7 here. It could be... No, we have well, it could be row 1, column 7. This way. If this is, okay. So, if this were a 7, that would guarantee this has to be 1. Because again, 7, 2 is already accounted for in box 9. So this has to be a different set of coordinates. The only other set of coordinates then is 7, 1. But if this is 7, 1, that would eliminate 1 from being here, which would mean 1 has to be one of these, and 7 has to be one of these. And this would then have to be 7, 1 also, which points to the same coordinates. So this can't be 7, therefore this is a 7 there. Remaining digits in column 8 are 1 through 6. Cannot be 2. So this is 7. That means 8 has to be one of these 3 cells. You cannot have 1 and 7 be the set, right? Because if you have row 1, column 7 be 8, the problem is 8 would then be on an arrow, and then you can't have 1 and 8 here because we already have this pointing to that cell there. So this cannot be 8, therefore it cannot be 1 and 7. The 7, it can only have a 7 and a 1. And this is 7, 1, this is 7, 1. 7 cannot be here, and 1 can't be here, because then that would be 1, 7, which points to an 8, which obviously can't be. So this is also 1 through 6, but can't be 4. Interesting. That means 7 and a 1 is an 8. So row 7, column 1 is an 8, and is pointed to. So that's 8. We have an 8, 9 pair here, and 8, 9 pair here, so this must... 8 and 9 in row 9 has to be in box 8. Okay. How many arrows do we have? We have 1, 2, so this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 arrows. Interesting. How many 9s can we have? We can only have one more 9. So one more arrow adding up to 9, because we have guaranteed 1 here, 2 and 3. Obviously this can't be 9 anymore. You could have 9 here. You could have 9 here. 8s. These are possible 8s. 7s could be here, but you could only have 2 7s. That's interesting. So only 2 7s possible. This can't be 7 because of 7 in the row. 6s could be here. 5s. 4. 3. And 2. So how many arrows do we have? We have 1, 2, so 4 plus 3 is 7, plus 2 is 9, 10, 11, 12, 13. We have 1, 2, 8 can't be part of the coordinated. So we have 1, how many 9s can we have? 1, 2, 3, 4, 5. So that's 5. How many 8s can we have? 1, 2, 3, 4. That's 9. 7s, 2. That's 11. 6s, we have 1, 2, 3 at most. So that's 14. 5s, we have 3, 16. That's a lot. Okay. 4 would be, so that's 16 plus 3 is 9. So those are the possible, so we have 19 possible cells with arrows. Interesting. But how many of them require 1? um, you could have 2, 2 here. Hmm. Huh. How? Huh. Hmm. To have 2, it specifically has to be 1, 1. To have 3, it has to be 1, 2, which is interesting. To have 4, you could have 2, 2, or 1, 3. To have 5, it's 1, 4, 4, 1, or 2, 3, or 3, 2. There's only one pair that can have the same digit. Oh, that's interesting. Okay. Because of that, so how many can we have without this cell and this cell, or this cell and that cell? This could be 1, 3, I guess. No, that can't be 1, 3. This is only 2, 2. You could only have 1, 1 here, 3, 3, 4, 4. So only one out of these set can be, but the thing is you could have a different 4 here. Okay, so let's count. This is one possibility because we only have one arrow which can be that way. Everything else is in the same box. So that's 1 here. Again, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Wait, that's... I eliminated 3 possibilities here. Or 2 possibilities, I guess. So maybe it was 20 before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It was 20. Okay. I miscalculated. So that means we only have 18. But that's still fine. Um, uh, we never have 7 in any... Okay, well, where's 9 in box? Okay, this cannot be 9. Ah, there we go. So we have all the 9 set. One is 4 with 5, and being 4, 5, or 5, 4, we don't know. The other one has to be 3 and 6. It has to be 3 and 6, so it cannot be, because it's row 3, column 6 is the 9. And that's pointed to. And this can't be 3, 6. This can't be 3, 6, so this must be the 3, 6 here. So this is 3, that's 6, which eliminates 3 and 6 in the rest of the box. And this can't be 3 anymore. This can't be 3 anymore. These can't be 6. So now we have 17 arrows that we can or positions we can point to. That means this cannot be 6 and 3 here, or 3 and 6. It has to be 2 and 6 in some way, and 3 and 5 in some way. Well, that counts for 1, 8 here and 1, 8 here. right? We have one of them going 6 and 2, or 2 and 6, the other one being 3 and 5, or 5 and 3. So these are the 8 arrows. You could have a 4 and 4 potentially being here, right? 8 cannot be here. Therefore, to match the 3 and 5, it has to be 3 specifically and 5 as the point. Obviously, this can't be 5 anymore. It has to be 3 as the base of the arrow, and then 5. So this is 8 guaranteed, which means this can't be 8 here. This can't be 8 here, which forces this to be 8 here in column 7. Therefore, we need 2 and 6 matching, so it's 6 and 2. So this is 8. So it's 6 and 2. Neither of these can be 2 as the arrow, so this is pointing here. This is pointing here. This must be 6 and 2 then. So we have 6 and 2 here. No 2 or 6 here. No 2 or 6 here. You can't have 4 here. I don't know why I have 4. This is guaranteed to have a 7 with a 1. This can't be 2 or 6 here. This is guaranteed again to have 7 and 1 to point to this 8. So this cannot be 7 and 2, which means this is 7 and 2 here. So this is 7, that's 2. It must be again 3, and then 5 is at the point. So this cannot be 3, and this can't be 5. This becomes, this 1, 5 pair eliminates 1 and 5 here. So this is 4, and this is 5. So it's row 5, column 4 is the 9. So this is 9, which means this cannot be 9 here. And this is pointed to by 5, 4. 7, 2 points to here. So again, 1, 8 points to there. 7, 2 points there. 3, 6 points there. 5, 4 points here. Then we have 6, 2 pointing to 8. 3, 5 pointing to 8. And 7, 1 pointing to 8. Okay, this cannot be 1, 4, 5. So this has to be 3. So 3 and 5 is already pointed to. Right, we already have a 3, 5 pointing to 8. So this must be 3 and 1. Which means it points to a 4. So 3, row 3, column 1 is a 4. So this is 4, which means this cannot be 4 anymore. And this is pointed to. So it could be 4, 1, 4, 2, 4, 3, 4, 4. Adding up to 5. Okay, cannot be 4 and 2. So this can't be 6. So this is not allowed 4 and 2. 4, 1 would force this to be 5, but then you'd have a 1, 5 here, which would eliminate all possibilities for that cell. So it cannot be 1. And this can't be 4, 1. I mean, it still could be 4, 1 here. Somewhere else in the puzzle. Where is this? Cannot be 9 here. This cannot be 9 here. Where is the 9 in box 8? It has to be here. Where is the 8 in row 4? It cannot be here or here because of 8 in the boxes. Can't be here because of 8 in the column. So this could, one of these two is an 8. Where is the 8 in box 1? Can't be here or here because of 8 in the column. Can't be here or here because 8's in the row, so it must be here. So this is 8. 9s. 9 in row 4 must be one of these two. 9 in row 2 has to be one of these two. Okay. That leaves this digit as a 5. We cannot have 3 or 5 here. This can't be 4. You cannot have 2 and 6 as a pair. 6 and 2 is already accounted for. 2 and 6 would have the duplicate 8 here in this box. So therefore, this must be 4. You can't have 6 and 4 adding up to 10 in the grid. So this must be 2 and 4 here, which makes this 6. So 6 can no longer be here. 2 and 4. So row 2, column 4 points to a 6. So that's 6. You can't have 3 and 6 anymore because we have a 9 there. You can't have 2 and 6 because that would force an 8 to be there. And that would have a duplicate 8 in that box. So this must be 1 and 6. The point to 7. So this is 7. So we have 2, 4, adding to up to there. So these are done. So this is red, 1 and 8, pointing to 9. 7, 2. 7, 2, pointing to 9. 3 and 6, pointing to 9. 5 and 4, row 5, column 4, pointing to 9. 3 and 1, pointing to 4. 2 and 4, pointing to 6. This is 7. 1 and 6, pointing to 7. 7 and 1 points to an 8. 6 and 2, row 6, column 2, points to a 8. And then 3 and 5 point to an 8. Okay. So this could still be 4 and 4, or 4 and 3. Remaining digits in row 1. We have 2, 3, 4. Well, okay. In box 2, we have 2, 3, 4, 5 remaining. 3 and 4, excuse me. 3 and 4 cannot be here because of 3, 4 in the row, so this must be a 3, 4 pair, which means this cannot be 5. So this is a 3, 4 pair, which means this can't be 3. This can't be 3 either. We have just 3 and 6 remaining in row 3. So this is a 3, 6 pair. This is 2, 5 as a pair. 5 cannot appear here. Remaining digits in row, well, this can't be 2 anymore. So this is, I mean, it could be 2, but it's 2 and 5. Remaining digits in row 2, we have 1, 7, and 9, right? Obviously, this can't be 9. 7 can no longer appear here because there would be 2 and 7 pointing to it, which we already have it pointing to. Or actually, can't be that. Can't be pointing to there. So that's 7 as a column, and 2 and 7 doesn't work. So this is 1. So since this is 1, this cannot be 1 here. If you had 2 and 1, that would force this to be 3, and we can't have a 3 there. So this must be 5 and 1, which makes this 2. So row 5, column 1 points to a 6. So this is 6. So this is done. And this is done. What can we point to now? This cannot have a 3. Remaining digits in row 7 are 1, 6, and 4. 1, 4, 6. This can't be 1 or 6 because of the 1, 6 pair in the column. So this is 4, which means this can't be 4. This can't be 4. So we have row 1. So row 1, this can't be column 1. Row 1, column 2 is not a 3. Row 1, column 3 is not a 4. Row 1, column 4 is not a 5. Row 1, column 6 is not a 6. We already have 1 and 6 pointing to 7. So that can't be there. Row 1, column 7 is not an 8. And we already have something pointing to row 1, column 8. So this can't be 1 anything. This has to be 6 here. 6, 2 is already pointed to. 6, 3 cannot be a 9. Therefore, this must be pointing to 6 and 1 as a 7. So this is a 7 here. So we can delete 7s here. So this cannot be 3, 4, and 3, adding up to 7 because we already have a 7 in the box. Therefore, it must be 4 and 4, adding up to 8. So this is 8, which means this can't be 8 here. This can't be 8 here. Where is the 8 in row 9? It has to be there. This obviously cannot be a 5. Matching this specifically. Oh, it can't be 5 because of that 5 too. 7 eliminates 7 here, so this is 9 and 7. This can no longer be 9. Therefore, this is a 9 here. 4 and 4 point to 8. So this is satisfied. We just have to figure these out. Let's see. This 6 eliminates 6 here, so this is 1. 4 eliminates 4 here, so it's 3 and 4. Okay. Where is the 1 in column 1? It has to be here. So this cannot be 7, 1. It's 5 and 3. So this is 7, 1. That leaves 2 and 3 remaining in column 1. This can't be 3 because 3 in the row. So that's 2. That's 3. We have 2 and 7 remaining in row 4. This can't be 7 because of 7 in the column. So this is 2 and 7. 2 eliminate 2 here. So it's 5 and 2. We have 7 digits in column 6. We have to have 4 and 6 remaining. And this can't be 4 because of 4 in the row. So this is 6. That's 4. We have 6 digits remaining in row 6. We have 2, 3, and 5 remaining. 2 cannot be either of these, so this must be 2 here. This must be 3 and 5. 3 can't be here because of 3 in the column. So this is 5 and 3. That leaves a 1 here. Remaining digits in row 5 are 3 and 5. And like either of them can be 3 or 5. Remaining digit in column 5 left is a 5. Remaining digits in column 4 is 2 or 7. 2 cannot be here because of 2 in the row, so this is 7, this is 2. Remaining digits in row 8, we have 6 and 7. 7 cannot be here because of 7 in the column, so this is 6, that's 7. 6 eliminates 6 here, so it's 3 and 6. That eliminates 3 here, so this is 5 and 3, which leaves us as 5 and 4. And that's a solution. Again, let's look at the arrows. 5 and 1, so row 5, column 1 is a 6. Row 4, column 4 is an 8. Row 1, column 6 is a 7. Row 3, column 1 is a 4. Oops, this is not green. This is supposed to be red. Row 2, okay, so these should be done. Row 2, column 4 is a 6. Row 6, column 2 is an 8. Row 3, column 5 is an 8. Row 7, column 1 is an 8. Row 6, column 1 is a 7. Row 7, column 2 is a 9. Row 5, column 4 is a 9. Row 1, column 8 is a 9. And rows 3, column 6 is a 9. So that's how you solve this puzzle. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.